Hi and welcome to the Neil Ashton podcast. In each episode, we explain some of the fascinating ways that science and engineering are changing the world around us. We talk to leading engineers from elite level sports like cycling and Formula One, to some of the world's top academics to understand how fluid dynamics, machine learning, supercomputing are bringing in a new era of discovery. We also hear some of their life stories, their career advice, and lessons they've learned on the way that I hope will be helpful to you too. So sit back and enjoy this episode. Hi and welcome back to the Neil Ashton podcast. Today, super excited about this episode. I'm a big fan of cycling. I'm a big fan of the use of engineering within sports, hence my love also of Formula One. And I couldn't think of a better person and team to speak to help people to understand what cycling is all about and why engineering and technology is such an important thing for the sport. And in some ways, cycling is becoming, in my opinion, and growing to become more like Formula One in being not only a human sport, but one where technology is really making a difference with really exciting innovations that then make their way to you and I, the public. So today I'm speaking to Kurt Bergin-Taylor, who's the head of innovation at Tudor Pro Cycling. And I kind of say in a way that if you're in the know, or you're a bit obsessed with cycling, like I am, I think it's pretty universally accepted that Tudor are actually one of the up-and-coming teams who I think have a very good chance in the next sort of 2 to 5 years of winning Grand Tours and some of the biggest races. As you'll find from the conversation today, you'll see they are taking really an amazing long-term view of how to take technology and really, build up a team and a process and science to really extract the maximum performance out of their riders and, of course, the equipment. Based in Switzerland with a very famous owner in Fabian Cancellara, who, of course, is one of the world's most famous cyclists with amazing palmares. And Tudor obviously is one of the world's sort of top watch brands. It's a very interesting company, but really what we're talking about today is about what is cycling, I suppose, a little bit, just to start off with. That's how we started the conversation, but really diving into the areas where technology makes a difference, where science makes a difference, and ultimately where there is innovation potential, which is the whole point of Kurt's job. So we go through things like nutrition, thermal, so how the human body reacts to heat and cold. We talk about some of the influence of aerodynamics around the development. You hear some of the stuff they're doing, their use of CFD, in terms of, mannequin, pedaling mannequins, how the strategy happens. You hear some about the number of race days that they have, the logistical challenges. Hopefully all just to give you a better sense of why, again, I perceive now cycling as being, if you're into Formula One, I always say get into cycling, because I really do think it's a great human and technological sport. But at the end, we talk about something that, again, it's a common theme of these podcasts, is advice for people wanting to get into the sport of cycling. But I'd say just in general advice for people wanting to do well in engineering and science and in any of the sort of sports engineering side. So yeah, I really enjoyed this conversation. I actually learned some things from it, and I was even more motivated with all the latest technological advances. So I hope you are too. I'm going to put some links in the chat about Tudor, and so you can learn a little bit more about the team, because again, I do think it's interesting, and hopefully from there you'll make your way to learning a little bit also about the sport if you're not so familiar with pro cycling. So yeah, today sit back and enjoy this episode with Kurt Bergin-Taylor of Tudor Pro Cycling. Maybe you could tell a little bit more about yourself and Tudor Pro Cycling. Some people listening are probably really into cycling and proper geeks and know about the different teams, but maybe just to level set everybody, maybe you could just say a little bit about you, what you do at Tudor, and who are Tudor Pro Cycling.
Yeah, absolutely, Neil. So really, my background comes from academic. So rather than some people in cycling who've come from kind of being a professional athlete themselves, mine's more from an academic background. I did a master's and then a PhD at Loughborough University in the UK, and that was really around kind of physiology and nutrition around cycling, really. So understanding kind of from a human component, and that really kind of enticed me into wanting to work within cycling. I was really fortunate at that point in time to be able to work with people on the track. So people like Dan Bigham, who's kind of a performance engineer now working within cycling also, and doing some really interesting things about that human equipment interaction and looking at how to move performance forward. And the track's a really nice environment for that because it's measured, it's controlled. It's like a science experiment every time you go on the board. So it's really has this culture for innovation. And that was something that I enjoyed so much. I really then decided I wanted to work within cycling. And then I had the opportunity to go to Canada. So I worked for the Canadian Federation on the track towards the Tokyo Olympic Games. And that was a really amazing experience in this kind of performance scientist role. So sitting in between the human, the equipment, the whole system innovation, really, and looking at that as a system. And that was such a great experience towards that games, and yeah, really had a positive impact on where I saw myself moving forward. Then COVID hit, and yeah, the whole world kind of changed. So that was really a point where we decided that we had to come back to Europe. I then had an opportunity to work within a professional cycling team, more as a coach, which was Team DSM at the time. I worked there for 2 years, mainly in that physiological kind of coaching role, and then the opportunity with Tudor Pro Cycling came up to kind of sit back in that more holistic kind of space. So working with the physical and technical components of cycling, which is where I kind of see myself really as a scientist, like not as an engineer, not as a physiologist, but really as a scientist who can kind of, make experiments, understand A versus B, and then find the right people with the expertise knowledge to kind of drive things forward. In terms of the team, it's a really interesting story. It was really born out of a team called Swiss Racing Academy. So there was a team in the past, a continental level team, which is like the third tier basically of cycling, that was there to encourage Swiss riders to be able to make it professional basically. So it was a team that was made so they had basic conditions to race, to have a salary, to have bikes. And that has been there for many years and was really kind of a successful pathway for Swiss riders to get into professional cycling. And in 2022, essentially that was going to close. So they struggled to gain their funding. And it happened at a really difficult point in terms of timing. And basically the guys who were left on that team were not going to be able to find another team because all the teams were fulfilled. And then the owner of our team, Fabian Cancellara, who's a very famous and successful cyclist from Switzerland, really saw this opportunity as really saving, the opportunity and careers of these young Swiss riders. And he put himself in their shoes and said, well, if I don't step in and give them this chance to ride, like what's going to happen to their career? And that's really the start of that process. Then he found out pretty quickly you need sponsorship, you need help, you need support. And that's where Tudor came in. Tudor being the watch brand, part of the Hans Willdorf Foundation with Rolex, as the main sponsor of the team. And that started in 2022. And now we're going into our third year of being Tudor Pro Cycling, really, which is has gone from strength to strength. We're a pro team, so second tier technically, but with like a world tour mindset. So we really see ourselves growing towards being one of the biggest teams in the world. And we're investing now in the kind of future of the team. We have a really long-term vision. We invest in the staff, we invest in the people, we invest in the science, really, because we know long-term that's what's going to make us at the highest level in the sport.
Great. Yeah, and I suppose, at least from myself watching it, Tudor's definitely seen as one of the top teams that potentially will get, promoted, I guess, in the coming years, and gets the invitations to the sort of grand tours. So I guess to many people who are not deep into sport, people may not know the difference between the second tier and the top tier, because Tudor tends to be in actually quite a few of the big races anyway. But before maybe we get into some of the more detailed topics, what's it like working for a team? I imagine it's a bit like Formula One, where there's a difference between the racers, the Lewis Hamiltons and the Julian Alaphilippes now, and the team behind. So what does it look like to work for a pro team? Like a typical week, how much are you at the races versus back at testing places in factories, just to give a sense.
No, I'd say the first thing is it's not very typical. So it's one of them industries where, especially in my role, kind of as head of innovation, it really sits across many different disciplines and with the first thing really with cycling is the season is so big. So we race from the middle of January until the end of October. So we can be racing at 3 races on the same day, all across Europe and even across the world. So it's a big logistical challenge, first of all, where everything occurs. We race roughly around 250 days a year in that period. So it's quite a lot of time on the ground. That's obviously without the preparation before, after, the logistics and things like that. So that during that period, really most of the time is focused on delivery, of race delivery, of performance delivery. So a lot of my support then is about optimization of setups, making sure that all the work we've done is executed. We have a really big push on the application of innovation. I think is really important, because we can do a lot of really cool things, but actually to get them to be applied at the right time with the right people in the right races is massive when you can have 3 or 4 races going on the same day. So that's a big push during the season. We still have our innovation team that runs basically 24/7 throughout the season as well. So we have a setup based in Silverstone. We have 4 full-time engineers. We have a PhD student. We have an industrial designer, all working on technological development. So we look at all the strands which we can approach really, and we move them forward. And we have 3 strategic themes with all our innovation. So we look from aerodynamics, because we know that's the biggest force that we overcome as a cyclist. We look from thermal, because we know thermal challenges are really, really important. And then we look from safety. So everything that we do, we always try and say, can we make it faster aerodynamically? Can we understand the thermal properties? And can we ultimately make it safer for the riders going into race and competition? And that can be if we're in the wind tunnel testing. It can be if we're doing fabric testing in the wind tunnel, whole system testing. Are we doing bike development? Are we doing CFD simulations? Are we doing velodrome testing? Are we in the field doing in-the-field measures of rolling resistance or tire development? Are we working with academic or industry partners on different projects? So it's really varied depending on what we have going at that point in time.
Yeah, I always find this fascinating, and I guess this is why so many people I know have this love of cycling, who also tend to be into things like Formula One, because the technology is such an interesting part of it. But you mentioned something about the thermal side, and that's something that I personally wasn't as familiar with until I personally did the Attack the Tour in like very hot temperatures, and was like, okay, thermal does actually make a lot of difference. So maybe could you explain a little bit more, because I think this may actually be useful for day-to-day cyclists who are doing things. What sort of technology or learnings do you get about cycling in sort of more extreme conditions, either very hot or very, very cold? How does that influence the performance of a cyclist?
Yeah, it's a really good question, and it's something we see more and more is integral to the performance. I think that 2 are very different, scenarios and situations. If we look at hot weather, we know that in Europe from probably May until the end of August, it can be 35, 40 degrees in some races, which we know is a really extreme environment. And we also know that the riders are getting fitter and stronger, which means they're putting out more power outputs, which ultimately means they're putting out more heat as well. Because, what you see on the pedals is actually probably only a quarter of the energy that's actually produced. The other three-quarters of that is thermal energy as well. So we know that you have these guys sitting in really hot environments, making a lot of thermal energy, and something has to give. And ultimately that is performance. You know, we see more and more that it can be so critical to performance. If you overheat, things start to shut down, your body protects you from that, and ultimately performance is part of a consequence of that. So we try and do a lot of research around heat. We do probably a few different strands. So we do kind of prevention and preparation, I would say. So we train the riders to tolerate heat demands. We know that that is a trainable stimulus, like getting fitter. You can also tolerate heat better. You get changes with your sweat response. You get changes with plasma volume. You get these physiological changes which allow you to basically deal better with the heat. So we do a lot of that preparation, and we've seen more and more in cycling. That is probably the thing that's really increased a lot in the last years, research around that area, understanding of that area, understanding the transient responses that can be done there. And then we also we do a lot of prevention stuff. So we look at pre-cooling. Can we bring down the temperature prior or even during exercise? Can we create a bigger thermal sink so that we know there's just more room to drive heat into? And there's lots of great researchers in that area. We work with partners quite a lot on that. We do a lot of work around fabrics and helmet design and things like that to understand convective cooling and material components and properties to really help with that. We're doing a lot of work around UV radiation because we know also there's the radiative effect of sun as well and things like that. So there's definitely a lot of work to be done from a heat perspective to really allow athletes to perform in them conditions. But like you said, also in the cold, it's something we see more and more. You know, some of the biggest one-day races in the world are in Belgium in the middle of March and April. And I can tell you now from being there firsthand, you want every layer of clothing you have on possible because the conditions can be really quite harsh. And that's something we also know. If riders get cold, if they get wet, it also has a massive detriment on their performance. So it's something we work on quite a lot to also understand what can we do from a material perspective, from an intervention perspective. How do we do the logistics around that? You know, there's so many things that ultimately come back to logistics. How do you make sure you have hot bottles that are available on the course when the whole peloton is strung out over a few kilometers, or doing clothing development to understand how to improve breathability or insulation in them in harsh environments. So yeah, we really try and do quite a lot of work around that to understand what's going on. And I think on top of that, just something we've generally been doing with the team is we do a lot of work to understand real world conditions. So it's something that's been a big project that we do around everything. Is we have all these tools and techniques to simulate in science. We try and take out the variables to get answers, but we're trying to also understand how we tune them variables to understand things moving forward. So thermal being a massive piece, but yeah, yaw, wind, turbulence intensities, all these different things we're trying to understand so we can really make more informed decisions with the tools we use and the data that we drive out through our techniques.
And maybe linked to that then, so what about, we've seen a lot of people now tracking, and I think there's some brand names that are shown on certain TV shows, commentary, where they talk about their recovery, their sleep recovery, and nutrition, and things like that. How much of that do you think has contributed? Or maybe here's the big question. You look at the current riders, and you look at them breaking records and seeming to go faster and faster. How much of that do you think is down to bike technology, so aerodynamics? How much of it is down to training, and how much of it is down to things like nutrition and sleep? Like, what do you see them all equal, or do you think some are more important than others?
Yeah, I think they've all played their part in improving cycling over the last kind of 10 years, I would say. I mean, taking them individually, nutrition has been a massive driver for sure. If you look at where cycling was 10 years ago and where it is now in terms of definitely all the research around carbohydrate intake, how to increase uptake, how to understand fueling. That's dramatically changed. And that we really know has helped drive performance forward, because if you can have more carbohydrate availability and you can oxidize more carbohydrate, you can generate more energy. And I think that has been a big push with performance. And I think you see now that the training volumes that are able to be sustained, the physical level within racing, and just what you see mainly under fatigue. I think that's the biggest thing that we've really seen the shift is not only the fresh capacity of riders, but what they can do after 4, 5, 6 hours, what they can do after days, weeks of stage racing. I think that a lot of that is down to really optimizing nutrition. And you can see even since I've been working in professional cycling, the investment from teams around the area. You know, we have 2 nutritionists, we have 4 chefs, we have a food truck, we have nutrition sponsors, we have nutrition partners, we have academic nutrition partners, we have data scientists that look at all the data that we generate around nutrition. Actually, you know, we measure hydration status, we look at energy expenditure to make sure that we match on a day on day, on a meal on meal basis across, you know, a Grand Tour, for instance. And a lot of that has really helped drive performance forward. We see riders can train more, get sick less, and perform much better, especially under fatigue. And a lot of that, I think, is down to nutrition over the last 10 years. Definitely aerodynamics and equipment development has moved forward a lot. You know, I think there was some teams early on that kind of clicked this. And I think, yeah, you know, it started really on the track. I think if you look at equipment development and where you see performance, I think British Cycling were kind of the real front runners of that from probably 2004, 2008 onwards on the track. And then starting to understand the physics involved. And as you know, there's such massive potential there. The rider is, you know, 80% of probably the drag of the system. And then what you wrap the rider in is a big part of that as well. So there's a lot of opportunities there that are now starting to be more and more understood. And we just see that the peloton just goes faster and faster. And for me, knowing the relationship between power and speed is cubic. It can't all come from power. You know, it's not that riders are all of a sudden getting to the cube more powerful, but actually the demands are coming down as well because we're getting more aerodynamic. We're understanding that speed relationship. So that's been a big driver for moving forward. And I'd say because of that, that's why at the team we're really, really focused on the safety part as well, because we just do so many innovations to make our riders faster, fitter, stronger. But we're also then putting them at more risk. You know, if you can go down climbs 10k an hour faster now, if you can take corners faster, if you can do this faster, that faster, we should also look after the riders more. So that's really why every innovation we do, we also take on that responsibility to make sure that we try and keep them safe as well. And I think, yeah, every team should do that, but we take that really seriously at Tudor Pro Cycling.
Yeah, no, that's it's definitely a sort of hot topic, isn't it, on the equipment versus the rider versus everything. It's one I guess you could dedicate an entire conversation
Absolutely.
to. But one thing I did on that point of maybe training, I was listening to Geraint Thomas on his podcast, and I think he was talking with Pavel Sivakov about like the different training, and they were talking about the sort of Team Sky where they basically just starved themselves and went out, comparing to now. Pavel was talking about the sort of zone 2, but I always thought it was surprising because I assumed that all the teams do that anyway, but it sort of made clear that he was describing that they sent a lot of junk miles, that people would just go out and because they're chatting with mates and they're drafting and they're so strong, the riders, that they were probably only in zone 1, where now they're trying. And he says he almost starts just training on his own because it's impossible to do. Is that something that you've seen as well as a very recent shift towards this more rigorous focus on extracting the maximum amount of all the time you're on the bike?
Yeah, it's really interesting with training methodologies. There's many ways to do it. And I think the longer I've worked in professional cycling, the more I've realized that it's really tailoring it to each individual rider. That's the most important thing. And the reason I say that is it's, they have the same demands, relative. I mean, a sprinter is obviously different to a climber or a classics rider, but they're endurance cyclists, first of all. So there's this key kind of physiological underpinning of what you're trying to achieve to, and then you've got these specific components on top. But I think where where maybe even when I was younger, people see training as you're training a machine. You have these inputs and you have an output. And what we know now more and more, and what I know working with humans, is that the input you put in doesn't always necessarily end up being the output. And the reason being is that, training is the one lever we can adjust as a coach or as someone working within cycling. But what we can't adjust is the stress on their everyday life, their family. Did they sleep well? What's their nutrition like? Are they happy? Are they depressed? There's all these different factors that go into a human being, and that what we understand more is that humans are very complicated systems. They're not just individual inputs, but they have all these inputs actually interact with each other as well. And I think it's more about, I find, tailoring the training relative to that. So you have your idea, you have your plan, you have your overall vision and goals and periodization, things like that. But it's being able to tweak and tailor that relative to what's going on within that rider's life, because you might have the best plan in the world, but if they're not eating properly, or they're stressed at home, or they're running a second business on the side that you don't know about, then actually your optimal training might not be correct, because it's good on paper and it moves forward. And I would say every training methodology can have its benefits. It's something that I really reflected on quite a lot now, working in different environments and different teams. You see lots of different ways of achieving success. And ultimately, I've seen things that, maybe I wouldn't naturally have done, but I've also seen them be very successful. And I've also started to learn and understand from them experiences that you can do things in many different ways. And some teams have certain philosophies, and some riders go really, really well from them philosophies, and other riders don't. And my philosophy is always to try and make the individual rider better. So I think when I look at kind of successful coaches or people that I really respect, it's the ones that make all their riders better, not just one. And I think that's where that individualization, that communication with a rider, that understanding of where they're at and tailoring their training to them is stronger, rather than just saying, okay, this is my training philosophy, we do it, or you don't.
Yeah, that's a good point. And I guess this is what's, maybe to people listening or to watching this who are into cycling, is always the tricky thing, because there's always a temptation to follow a specific guide because you hear that somebody else does it. But you don't know whether should you just follow it and you just need to suck it up and just, deal with the suffering, or is it just not well suited to you and you would be better doing something else? It's, there's so much, not misinformation, but there's so many different theories out there, isn't there, that it's hard for an amateur cyclist to really know what to follow. It's especially when it's sensationalized as well.
I think so, especially when you have a full-time job and a family and everything else, and you're trying to do this as on the side. It is really difficult. You want to try and extract as much as you can out of it, and that's where I think it can be difficult, because professional riders, they ride the bike. That's their full-time job, and actually the other thing they can do is they can recover professionally, and a lot of amateurs can't do that. And I think that's the challenge, is you want to do what the pros are doing, but actually you can't do the recovery part. And we know that adaptations, they don't actually occur when you're on the bike. The stress happens then, but the adaptations happen afterwards. And if you can't have the adaptive processes, then maybe the training doesn't fulfill what you want it to achieve, because you can't do the other proportion of that.
Yeah, no, that makes complete sense. So what, maybe going a little bit more into the bike side of things, where do you see the sort of big performance areas nowadays? Is it, in the bike, the fabric, the tire choice, where are some of the maybe interesting areas that you think have led to some gains, and maybe where are sort of future areas that people are starting to explore now?
I think the biggest thing you can look at really is the whole system approach. Like for me, this is, really critical, looking at the rider and all their equipment as a whole system. The more kind of information or testing I've done, what you see is if you change one component of it, it's a cascade and everything else is interacting with that. And if you can't just say this helmet is fast, this skin suit is fast, this bike is fast, it's in what context, with what rider, with what demands. I think that's the really kind of where I really see the innovation happening now on that individualized level. Because there is just such different demands on them individual user cases. So for instance, a sprinter, we know sprinters go 70, 80 kilometers an hour in the final. And we know they have to have very aggressive positions to try and put their heads in certain places. And we know because of all that we need to understand certain flow structures, certain stiffness, aerodynamics. We need to understand vision. We need to understand how all that interacts with each other. And we need to understand fabrics relative to that rider at them speeds. Whereas that is completely different if you look at a climber, for instance. The demands of a climber are going up the climb and probably coming down the climb on the other side. And if we look at the whole system, the position, the orientation they're in, it's a completely different system. So one helmet's not going to be perfect for both. One skin suit's not going to be perfect for both. One bike's not going to be perfect for both. So I think what we'll see in the industry of cycling is long term is this individualization development. So can we build stuff on an individualized basis? Can manufacture methods cope with that? Can we find ways to really individualize it? And I think that's where we see real benefit in terms of the performance moving forward.
Yeah, that is so interesting. I must admit that sort of aligns to some of the findings that I found, when I was working on some of the British cycling stuff. It's almost an unbelievably complicated optimization problem because you know that the bike, the rider, the wheel, the helmet, and what you really want to do is test every combination with every other combination. And then, whereas I guess a lot of the time, because of commercial reasons or partnership reasons, you're like, hey, helmet manufacturer, independently just give me a good helmet, but you haven't been involved in that. So is that what you're trying to say, that you're trying to be more involved with the partners so you're not just buying off the shelf something they've made, but potentially it's a little bit more aligned to your needs and how that interacts with the other bits you have?
Yeah, 100%. It's something we've really driven forward in the last years, and it's still a continual process, but we have what we call like reciprocal relationships with our partners. So we really make sure that when we select our partners, they're partners that want to go on this innovation process with us. Because it's not easy, it costs money, time, effort, and we're really, demanding of what we want. But we're also, which I think is quite unique, we also have the capacities in-house to actually put time and resource towards them problems. So it's not that we just knock on the door of our partner and say, okay, we want a new bike or a new helmet. We say, no, we want to go on this project with you. We understand the demands that we're aiming towards. Let's do it in a collaboration. So, a perfect example could be when we're developing a new helmet, and we were developing a new helmet with a new partner, and we had wind tunnel trips happening in their location, wind tunnel trips with ourselves in the UK. We had riders there. We had 3D pedaling mannequins. We did simulation. We did all these collaboration approaches, thermal, fit development over a long period of time to really make sure that the initial product we had was as evolved as possible in the time we had. And we continue to try and do that across all the things you said, the bike, the tires, the wheels, the clothing. It's something that we're taking ownership of internally as a cycling team. And I think that's quite different to maybe many other cycling teams, is we invest resource in that. We have engineers, we have an industrial designer, we have fabric experts in-house that complement the expertise of our partners to really make sure that there's investment from our side to tailor the products to exactly what we need. So we really start to understand that and move it forward. And we see that will really be our way of moving forward and being at the forefront. And it takes time, but I think it's the right way to do it. Investing in that innovation process is where we see really critical to our performances in the future.
And how easy or difficult is it, or a barrier to get the riders involved? Because you've said at the same time they're off doing 60, 70 race days or however long some of them do. How easy is it to get them to come, to a test or to go? Is that a limiting factor sometimes?
Yeah, there's a few things to that. I think the first thing we do is whenever we speak to new riders, we always tell them about our process, that we're an innovative team, that we take risks, that we push the boundaries on these things, and that ultimately that requires investment of time as well. And for some riders, maybe that's not what they want from their cycling team, and therefore it's a conversation to have early on to set expectations. But we've also realised as we move forward that still it's impractical to expect riders to be available 24/7 for these learnings. So what we really try and do is we try and leverage methodologies that allow us to do a lot of the stuff beforehand. So we do a lot of simulation. We have 3D scans of the majority of our riders. So we can do a lot of digitalization. So we can do a lot of CFD computation. We can do a lot of clothing optimization, fit. We can do a lot of understanding external to them even being needed. We also create mannequins. So we have mannequins of, our higher priority riders, pedaling mannequins that allow us to go to the wind tunnel and test things without them being there. So we have really high repeatability methods. It's also what we find is with riders, I'm sure anyone working in with humans and doing testing, is you see that it's really difficult to get reliable data because naturally you're a human, you get tired, you get hungry. Whereas if you have a mannequin, you can run them for 10 hours a day and get really good repeatability and not have to feed them. So it gives you a lot more scope and capacity to do that work. But there always needs to be a validation step, and that's really important. We always make sure that all the work we're doing loops back to either field testing or some kind of simulation tool, be it wind tunnel track testing in the field, to validate the findings that we find from doing all this kind of in detailed research. And for sure that costs time from the riders. But we try and educate our riders on why we're doing it. We empower them. We show them the data. I think we're really open from that perspective. We give them that information so they understand, okay, we're asking you to do this and we've provided you this and this is the consequence. And for the majority of riders we work with, they're really involved in that process and they really understand it. I think it's one of the nice things with cycling. It's such a data-rich sport that actually a lot of the cyclists understand. They understand watts, they understand watt savings, they understand speed gain. There are even some of them, they understand aerodynamics and they can quote you the equation for X, Y, Z. And it's definitely something that's really powerful in cycling that you can have that conversation. And they know how hard they train to try and gain 10 watts. So when you can tell them you can find it from something else, that they're usually quite grateful and willing to invest that time in it.
And do you see a shift between the younger riders who are just coming through from the development squads and the older riders? Is there has all of this change the past 5-10 years meant that the younger riders are far more educated than maybe the older generation are?
Yeah, that's a really, really good question. It's something that we see quite a lot in many different ways. So I think generally the younger generation are a lot more, like you said, maybe educated on it and thoughtful of it. But I'd say sometimes also obsessed with it, which can be quite interesting. It's sometimes they think it's a PlayStation game and it's a laboratory and it's it's only this equation of numbers and clothing and equipment and things like that. And what you actually see is, you've also got to make decisions within a race. You've also got to be able to tactically and technically be able to execute on a bike. And they're things that sometimes are often overlooked, with the younger generation, that's what also wins your bike races. It's not just all this physics, but actually it's a sport and there's decisions. And we had some really interesting talks with Julian. Like Julian has joined the team recently. And historically, he's not a man who's obsessed with data or insights and things like that. He's a guy who wants to race his bike, but he also understands the value of it. And he trusts that if we say, okay, we're going to do X, Y, Z, we're going to try and improve it, that we're working on that in the background, and he's really open to that. And that was one of the things that was really important when he joined the team, that we do this stuff, but he also has that passion about racing your bike, and educating the younger riders on tactics, technical positioning. They're things that we also know are super important as well. So it's definitely an interesting time in cycling from that regard.
Yeah, and I think that's a really good point, actually, because I feel in some ways that, Team Sky arguably were the one that really heralded this shift to a more like marginal gains, obviously, and data-driven. But I would argue that potentially it turned, maybe it was the personalities who were in the team, but it was a little bit mechanical, a little bit, the emotion maybe went out of it a little bit, which led to a bit of a backlash almost on some of that. But now you've got people like Tadej who clearly do a lot of the data stuff, or he does a lot of training and the team, but it perceivably seems more impulsive and more emotional, a bit like Julian Alaphilippe. So I guess the sport has to balance both, doesn't it? If it becomes too obsessed with all the data and sort of mechanical stuff, then the human side and what we love of seeing riders may sort of lose that as well. So I guess maybe that's the balance, isn't it?
Definitely, it's storytelling. It's people. It's and I think the same thing happened with F1. It's finding a way for people to build them emotional relationships, to tell these stories, these experiences. That's just as important as all the tech that allows for them things to happen. So it's definitely this balance for sure.
Yeah, one thing that I would love to see, and I assume it's been discussed and maybe it's just not happened for various reasons, is I find the riders are so good at masking their pain that you don't always know. And as a sort of more geeky person, I would love, and I know they've started to do this a little bit, but I would love to have their body temperature, their heart rate, their power, in real time. So I could sort of see how much they're suffering almost, because sometimes you see somebody and you think they're doing great and then they suddenly just go and you think, surely, he's felt that for a while, but he's just hidden it. Do you know what I'm talking about? I don't know.
Yeah,
data could
100%.
be used to make the sport more interactive in a way.
It's a really good point, and it's something, as Tudor and people I speak to have thought about a lot. It's how do you improve that viewer engagement? Can you give more insights to allow for a better experience? And I think it's something that F1 did over the last 5 or 10 years with cameras and having more of the radio on the TV and things like that. I think them things they're the really nice insights that you gather and you think, oh, okay, yeah, that I have this unique insight on what's happening in an F1 car. And I think cycling can definitely move forward. There are some initiatives. There's an initiative called Velon, which is kind of a separate company that kind of is attached to certain races, and they have more data insights. So they share certain insights. They have in video footage of the races, but apart from that, it's quite controlled from the UCI. So it's not something a team could do individually. It's not like we could put cameras on every bike and release it to the world. It's very restricted from that perspective. So it would take from a UCI level, from an organization to kind of take it forward. But for me, it's something that should definitely be done. And if it's done on a level playing field, there's no negative consequence of that. If everyone has to have a camera, then it's the same, and then you get all these insights. So no, I would be definitely for that.
So maybe one, you mentioned a little bit, and maybe this is teeing a little bit to some of the AI or machine learning side of things, but maybe first on the strategy side. So you've talked a lot about nutrition, bike design. How much data can be used to optimize strategy, when someone should try? Because sometimes I watch a race and I see somebody try to break away, and I think surely there's an optimum power for them to just get that break, to the elastic to get. And you think, if they could have just gone for another 10 seconds, maybe they would have actually made it. Is there any way that you can look at that sort of more strategy side of things with the data-driven sport as it is now?
Yeah, it's something I think a lot of teams are trying to do and excited about. Like I said, cycling's a very data-rich sport, so we have a lot of data. We have second-by-second data on all our riders for maybe 1,000 hours of training a year, for many, many years. So we have a lot of data there, and I think people are now starting to harness it. We definitely have quite a few projects that we look at. We try and look at certain riders. Can they make it in certain races? Maybe sprinters, for instance, can they pass certain climbs? What's the probability of chances of success to get to a certain point? Do we expect to break away or not? I think is quite an interesting one. Do we expect it to succeed? Should we participate in that on certain stages? I think there's lots of things that can be done. There's a lot of stuff around race choice and picking certain races for certain riders, understanding where their kind of potential is, for results. There's definitely a lot of optimization for those kind of data insights from data that's driven there. And then I think also with AI and the other kind of emerging techniques, there's lots of stuff to be done around all the CFD computation stuff that we do. We've found that we're really in the earlier processes of that, but every time we run a simulation, every time we generate some data, we know that there could be long-term potential insights in that data. So it's really about understanding how to sequence, to store, to evolve, to know that maybe not now, but in 1 year, 2 year, 5 years, there's insights that can be gathered from that. And I think it's making sure you're in the right place now to set them things up so that in the future it is definitely possibilities, that's for sure.
So would it be fair to say that probably cycling has, for the past 2, 3, 4 years, been moving far more to a data-driven tech, but we're only just entering now the age of really AI for it? That would it be fair to say that most of cycling is probably only just now really getting into potential? So that could be something in the coming years that could be used, because as we talked about that sort of design optimization, you've got so many different choices. That seems, or even logistics, I guess AI is a classic tool for optimizing things.
Yeah, it definitely is something I think we'll see more and more of. I think the sport itself is getting more professional, more funding. It's having, more people like myself work in sport, kind of sitting in between the lines of scientists that are kind of integrated. And I'd say most of the highest level teams now are starting to understand that and invest some of their resource in that, and not just in better riders or things like that.
So how about for Tudor in particular, what does the sort of future hold? What's the big target, I guess, this year and the coming years that is driving all this towards? Do you have some very specific things that the team is trying to focus on and succeed?
Yeah, I think as a team, I mean, we have quite a lot of strategy, I think, in terms of where we want to go. We're really fortunate that we're a long-term team. We have a long-term vision and a sustainable long-term vision, which I think is quite unique in cycling. I think the first priority of the team is really to be in a position to allow us to have the full race calendar. So for people who don't understand cycling, if you're not a world tour team, if you're not one of the top 18 teams, then essentially you're kind of at the will of the race organizers to invite you to the biggest races. So we know if we achieve a certain rating every year, being one of what's called the top 2 pro teams, then that will allow us to have a full race calendar. And then once we have a full race calendar, it then opens up all the opportunities in terms of where we want to go and how we want to do stuff. At the moment, because we're a brand new team, we have to rely on them invitations, which can make planning and strategy quite challenging sometimes. So that's our first real goal. And really the long-term goal, especially from my perspective, is around the innovation team, is really to just be a world-leading innovation team with regards to performance. So safety, aerodynamics, thermal, from all the opportunities, having this whole system, individualized approach around key riders, looking at them as a whole system, is really where the next 5-10 years look like. And we can really do that ultimately because we have a sustainable platform to launch from. I can imagine it's quite hard if you're in a team that's unstable to think, I'm going to do this now and it might not pay off for 5 years. But we're in a real good place that we can do that. And I think that really allows us to be a front runner in the future and really invest in this kind of data-driven, science-driven approach.
So maybe turning maybe towards the end of this chat towards a topic that I personally am always interested in, which is the advice for people and engineers wanting to get into the sport. You came through the PhD route, and then you sort of worked through, as you say, like different sports and then track and then thing. Looking back, what sort of advice? Maybe let's break it down from a. Is it Well, first of all, the high level advice, and then maybe we can pick apart some stuff.
Yeah, I think about this a lot. I really try and take responsibility on myself to look back at when I was younger and what were the reasons why I'm in the fortunate position I am now, and I really try and give back to that because for me, some of the things I really reflect on is I had really good mentors. Like I had people who went through that process and really allowed me to connect, to discuss, to learn, to evolve, grow, and I think that was fundamental to where I am today, having them mentorships. If it's just having a coffee, picking the phone up, what do you think about this? Oh, I have a friend who does this. Why don't you have some conversations? I think that I'd really encourage that spirit of, mentorship is really important. And I think it's responsible both for young practitioners, but also for experienced practitioners like myself to also give back, I think is really important. I think the other thing is work ethic and doing your time. Like it's something that I really, pride myself on and was something that really allowed me to move forward. I was the first person to say yes to a volunteer opportunity to fill up bottles on the side of a rugby pitch, or if it was to go to a swim meet in wherever and at 6 a.m. in the morning, just to be embedded within sport opportunities. And I really tried to take on as many opportunities as I could when I was younger, just to see and feel and understand why I wanted to work in professional sport. And that goes a long way, because when people see you're just willing to say yes and to understand and learn, I think can be really valuable. And that's a trait that I really look for in people. I look for that kind of willing spirit. I think a lot of people, in my experience, you can train them for the skills that you need, but actually the character and personality of someone is kind of ingrained. And I think if you can show that, you're willing to work, to listen, to put effort in, to be passionate about something, I'd go for that any day over someone who has 5 years experience of doing the job already. I really look for that. So that would be some of the things I would say: mentorship really, and that kind of spirit of just willing to do.
And what about from a practical point of view? What sort of are you looking more for? Like engineers, more for sports science, more for like data science? Is there certain sort of skill sets and maybe degrees that put you? I guess traditionally sports science would have been the route into a sport. Is that still the case, or do you think it's more about like engineering and data science now?
I'd say historically you're correct. It was sports science, and really probably was the first investment I'd say from professionals, at least in cycling, was sports science and understanding sports derived things, physiologists, and what you saw is then people generally then sat like myself across many spectrums. We did data science, we did performance analysis, we kind of did the bits that we did some nutrition, maybe we did different things to really allow performance to move forward. And having that generalized skill set was probably the way in, I'd say, 5 or 10 years ago. I'd say now, sport within cycling in particular, there's enough investment and understanding that these really specified roles are coming in and become really important. And I think for people who have them specific skills and the passion for sport, there's some really unique opportunities growing. So, for instance, data science, I know a bit of data science, but not to the level of a data scientist. And I think if you can come in with them skills, but also the conceptual understanding of cycling, there's massive potential for that in the future. And the same with engineers, having aerodynamic engineers, design engineers, mechanical engineers that have this desire to work in cycling and this conceptual understanding of cycling. I see more and more opportunities for them, either within professional teams or within partners that work with teams. And you see that's definitely a growing field now, really, that high level science within sport, and particularly within cycling, is more and more opportunities.
Mm. And are there any recommendations? When people sometimes ask me about Formula One, sometimes I say, okay, well, if you can't get into Formula One, try and do with a lower, quote unquote, lower formula first, just to get the practical experience. Is that something people can do with cycling, or is that a slight almost gap that, it's either you've done a university course or you work for a cycling team, but how do you get the experience to know? Is there any things that you're aware of that people can clue themselves up on cycling specific knowledge?
Yeah. Yes, it's definitely difficult to make that bridge, like you said. I'd say one thing that I've seen successful people do is using the opportunities they have through their time as a student to allow for opportunities to interact with professional sport. So, if you're an undergraduate or a master's student, you have to do a placement or you have to do a final year project, trying to drive that final year project in a direction where you can interact with a professional team is a really nice way, because if you can approach them and say, I need to do 200 hours of X, Y, Z, I need to do simulation, I need to do wind tunnel tests, I need to do in the field research on this topic, and I think it's really interesting for you, and we can shape the question to answer your problems. They're the kind of things that would get me really excited. Students that have that initiative, that have that capacity, to drive this thing forward, and it's it can be a 3-month interview, and even within our team, we have one member that came directly from that kind of process. Showed initiative, stepped through it as a master's student, and really secured an opportunity straight from graduating in professional sport, because he showed that initiative to on how to move himself forward. So I'd say really try and shape the experiences you have towards sport, and bring a question and a solution rather than just asking for experience. I think that's something that's can really help you break into professional sport. And also don't worry when you get a no. I think if I remember my initial period, I applied for so many jobs, opportunities, and sometimes it's not the right time, the right place, and that's completely fine. And I really believe they shape you to the person you are, don't give up when it becomes difficult. I think that's just something that really allows you to break into difficult industries.
No, that's a great piece of advice. And no, I actually, the big picture, I guess the reason why I was so keen to speak to you and generally talk about cycling is I feel like engineering, or sort of sports side of engineering almost, is some people turn away from engineering because it's almost perceived as not being exciting, or it's not being fun, and they see football or whatever or something as being fun. And I suppose one of the things I've always been a fan of is that if you can link those two things,
yes,
then it's like you have the pleasure of working on something that you actually like. And I think Formula One was traditionally always that thing, but I think it's just hard to get into. That's just the one. Yes. And there are so many aerodynamicists working in a team, 50, I don't know, maybe 70, that you're just working on, the equivalent of optimizing a spoke on a wheel, let's say, where I guess if they work for someone like your company, they're going to be working the whole thing probably. Yes. So it's like, it's more rewarding maybe actually to sort of go into a cycling thing maybe than Formula One in a way. So it's almost, maybe I'm encouraging, if there's people listening, to maybe consider getting into the sort of cycling side of engineering, because it could be more fulfilling potentially than your traditional Formula One.
Yeah, it definitely offers that opportunity to go through the whole process as well. As a sport, we have much less budget. We're more, agile with our resource. And if you're an aerodynamicist within cycling, you work everything from, conceptual CFD all the way to real world validation with a human being. And you get to have all them touch points across that piece. And I think it makes you a much better practitioner when it's like that, when you can understand from really complex kind of, fundamentals all the way down to convincing a human being of the work you're doing and getting their feedback and having a holistic approach. That to me is what gets me out of bed every day. I get to do this really complex science, but actually apply it, and then ultimately seeing it in competition, and watching it on TV or being there present and, you know, having your heart rate at 180 beats a minute when they're going into a final and thinking, yeah, I played a small part in that. That's a really nice feeling, and I would definitely encourage people who are interested to reach out and to look at opportunities within cycling, because it's definitely a growing space moving forward.
Great. Well, thanks so much, Kurt, for chatting today. I'm hoping people, you know, got the same that I out of this, which is just this excitement, I guess, for cycling. And, you know, for Tudor, I think it's great when there's these relatively new teams coming in, trying to sort of shake it up. And I think it's good because it makes the more established teams sort of, whereas they've got to shake up, and it's good also for people who wanted to get into the sport, that there's more companies, more jobs. So yeah, thank you so much for speaking and educating us all on what it's like to be a pro cycling team.
Perfect. Thanks, Neil.